Welcome back to this YouTube tutorial series on implementing templates/generics in C. And in today's video, we're going to be implementing the contains method and giving some implementing the free value and the comparator function inside our main.c file, as well as giving a good example. So let's go to our stack.c file and implement the contains method. So I'm just going to copy this and paste it here. So what we're going to do is we're going to perform a linear search. We're simply just going to go through every single node and see if its value matches. So to do that, we're going to say stack node top, or let's call this temp, is equal to the stack.top. And there's different ways to do this. We can either use a the same format using a while loop, while the size, or what we can do is we can say while temp.previous does not equal null. So this is simply going to iterate through every single one of the temporary variables. Actually, not previous, temp. So while temp is not equal null. So if the stack is empty, then temp should equal null, and this while loop is going to break and it's going to exit. And the way we iterate through is we're going to say temp is equal to temp.previous. So here in our little example, if we have no values, then our top is equal to null, temp is equal to null, and like I just stated, it would break. Let's say we have these two values. Our temp is equal to the top. We iterate through. Our temp is now equal to the previous value, and temp is not equal to null, so we continue. Temp is equal to its previous. The previous is null, and then we break. This way, we get rid of any kind of error cases of trying to access a pointer that's not initialized. So what we're going to do is we're going to say integer comp is equal to myStack.compare of the temp.value and the value being passed in. So I forgot to actually add this as a parameter. We're going to say const void value. So this is the value we're going to compare against. And we're making it a const because we do not want to accidentally change any of its attributes of the value. And we're going to say if comp equals 0, return 1. And if we return 0 occurs when they match. And let's say if it breaks out of the loop and we reach somehow line 24, that means either the stack is empty or there is no match. So we're just going to return 0. So now we have a fully implemented template for a stack data structure that contains a void value as the node and contains two pointer functions, free value and compare, where free value is used as a user-defined function for actually freeing the values, and the comparator function is used to compare things. So as we use in qsort, the comparator function was used to sort the data. It's also used to compare the data in a contains method. So now what I'm going to do is I'm going to actually implement a few examples. So to begin with our examples, I'm going to make two structures. I'm going to call one schedule. It's going to have integer pointer data type. I'm going to make, say, type def struct schedule, which allows us now to reference the struct schedule by schedule. And then we're going to make an employee structure. And this employee structure is going to have a name for the employee, and they're going to have a schedule. And we're going to do the same thing with the type def. So here we're going to now make a stack, and we're going to push these employee structures into our stack. But before we can do that, we need to have our user-defined comparator functions and free value functions. So let's start off with our comparator. I'm going to say integer compare, and we don't have to actually name these pointer functions the names that they're called by, such as compare. So we can actually call this compare employee, just in case we have multiple structures and multiple instances of of stacks, so we can actually point to multiple functions. So our constant void right So what we can do here is, since we have these values, if we go back here to our stack.contains, we're comparing the values from our stack nodes and the values being passed in. So we need to cast these back into their employee pointers. So L is equal to employee of left, R right, or R is equal to the cast of the employee of the right, and we can compare them by their names using the string comp function. So we're simply going to say return string comp of the L.name and the R.name. Now this already follows the format of returning -1 if L is less than R, returning 1 if R is greater than L, and returning 0 if L equals R. So the next thing we need to do is make our pointer function for the free value. So we're going to say void free value of employee. We're going to pass in, this time not a const, but just a void pointer, because we're actually changing the values. And we're going to say employee object is equal to, we're going to cast this we're going to cast this void pointer of the value back into its original data type. And then what we need to do is first free the name of the employee. Then we need to free the data stored in the schedule. Then we need to actually free the schedule itself. Then we need to actually free the employee structure itself. So there we have it. We've actually implemented both our pointer functions, and hopefully you can actually see why these need to be user-defined. Simply because if you're making a templated data structure that holds different types of data, when you call it its destructor to get rid of it and release its memory, there isn't a universal free function that just frees data. You need to actually have a custom implemented way of getting rid of your dynamically allocated memory. So hopefully you actually see why we need these two functions, and hopefully you can understand the reasoning behind them. And so now I'm going to actually implement this in our main function. So we're going to declare our stack. I'm going to say stack.initialize the address of my stack, which passes in a double pointer. We're going to pass in our free value and our compare employee. Now we're simply going to make an array of names that we're going to pass on to our employee structs. And let's make 3 of them through this for loop. So we're going to make our employee object is equal to employee cast our malloc size of employee. Then what we need to do is get the name, the schedule. Let's do this first. Allocate its memory. Size of schedule. And then what we're going to do is we're going to allocate the integer value for the schedule. And even though the data value can store the memory address of a single variable, what we can do is make this a vector. Excuse me, not a vector, but an array. So what we can do here is we can allocate memory for our scheduled data is equal to integer pointer malloc size of int times 5. This now takes the size of an integer, however many bytes that is, times it by 5, and stores that that memory, or the starting index of that memory location, inside our pointer here. So now what we can do is we can index through this data like an array. So we can say for integer j is equal to 0, j is less than 5, j plus plus, and we're going to set our object schedule data at the jth index is equal to j. So this is simply just going to make our array equal to 0, 1, 2, 3, and 4. So now what we're going to do is we're going to take our object name and allocate memory for it, size of char times 15. So we're making a char array, and what we're going to do is we're going to loop over, and we're going to initialize all of its entry values to the null character. So we're going to say object dot name dot j is equal to the null character. This is because whenever we want to call the string comparator function, we don't want to accidentally have leftover space here and cause a segmentation fault because of using uninitialized values. So now what we're going to do is we're going to say string copy of our object.name, and then we're going to copy the names inside this string array. And we're going to pass it at the ith index. And then what we're going to do is we've initialized all the variables and their data, so we're simply going to push this onto the stack. My stack, and we're going to push on our object. So there we have it. We've created our employee structures, initialized their data, and pushed it onto the stack. And in the next video, I'm actually going to go over popping these values and comparing them. Excuse me, not comparing, comparing them. So stay tuned.